All right, kinematics. So one of the other parts of the physics program that I wrote my senior year of high school was kinematics. So kinematics is like the study of motion in terms of if you have a bouncy ball and you toss it up into the air and it comes back down and you catch it, that's kinematics. Every second of that travel of that arc that ball is traveling, you can describe with math. You can explain, you can calculate with the numbers with these equations. Um, I'm not gonna make this a physics lesson, but the gist of this is d is equal to distance, v is equal to velocity, or like the speed that something is traveling at. T is equal to the time that it traveled. A is equal to the acceleration or deceleration, so that's getting faster or slowing down. And a, not a, oh yeah, so the different v's here, and we'll get into this in a second, but you have a velocity initial and you have a velocity final. So you have the speed you started at, and let's say you sped up and then you ended at a specific speed or velocity, right? So your velocity initial and your velocity final are different because you have an acceleration that is happening over that period of time. Great. So we know our equations. Well, we have some problems. First off, do we actually want to program this? Well, it's the same equations. The equations aren't changing. Our inputs are going to change and our desired outputs are going to change, but we can just program that away, right? I mean, probably. We kind of did that in the last problem with the trigonometry stuff. If you don't have certain inputs, how do you tell the program, I don't have this input, calculate for this output, right? So first off, you have to select the right equation. All right. Then you also have to filter for the variables that you have and the variables you don't have, and then filter for the variables that you want, and if there really are any of the variables you don't want, but if you can, might as well just make the calculator give you everything. That way you have all the outputs that you could possibly need. And then once you filter for which equation you want to use or which equation you can use, then do the calculations and then give me my output. Is this really worth our time? I would say so, because you're going to be doing a lot of kinematics, and if you can just have a single program that you put your inputs to, you know it does the math correctly because you did the math yourself, and then it'll give you the algebra yourself. Then boom. So it's a good investment of your time. Great, on to the program. Very confusing stuff. This is a comment. Anything in quotes with no command in front is a comment, meaning the calculator won't read it as a command. It won't, display kinematics. It won't throw you some error. It'll just run over that like it's nothing. But when you're looking at the code, you'll understand, okay, this is telling me that this section is on kinematics. Got it. Label. The label command is like a bookmark. It's like a folder. So if I want to, at any moment, and we'll actually see that in a bit, go to specific sections of code, I can say go to 2, and it'll run this from the line down. But if I don't want to run this section, which, again, I'll explain that in a second, an actual use that I use that for, I don't want to run from here down, I just want to run from here down, then I can say go to 22 instead of go to label 2. Labels aren't, they're like comments, where they're not shown, they're not commands explicitly, let's say, they just divvy up the code. And then you can use them if you want, but they're, again, kind of like comments. You can say, this is label 2, but never actually use that as a function, because they're like the lock to a lock and key, where they're just kind of there. And if you use them, great. You can actually lock your door. You don't have to lock your door, but you can. So you can actually use the goto function, which I do down here, go to 22 and go to z, and it'll go to those sections, it'll actually turn the lock, it'll do the thing, and it'll run this code from here down. Great. So one store x. Yeah, I might as well talk about this now. So what I wanted to do is run this from label 22 all the way down. I wanted to run this section twice. And the reason for that is because if you can only solve for one of the variables, which I did actually have, it was only solving for just the one variable that it could. And I was like, okay, well, I want to solve for all variables, right? Because if you have a minimum of 3 inputs, so if you get your 3 inputs and you want to solve for these 2 outputs, but given those inputs you can only solve for one output, you don't want to have to then rewrite or rerun the code with your now 4 inputs and solve for the 5th, right? So if you just have it run this code twice, because effectively it's doing the same thing. It now has 4 inputs, and all it's got to do is then solve for the fifth. Great. So this is saying, okay, well, this is our first run. Right? This is the first time we're running this code, just as a heads up, as a marker for later. And then it asks you for your inputs, and then it'll skip over this because it's a label, it's just a bookmark. It'll run the entire code, and at the very end, it'll say, well, add x to 1. So this is where we're getting ready for our second run. And then it's saying, well, if x is less than 2, so if this is only your second run, which we already said it was the first one at the beginning, we're getting ready for the second run. If it's equal to or over your second run, then go to 22. Might have gotten that wording wrong. But it's going to go to here, it's going to rerun this code just like I said, it's going to give you your fifth output, and then it's going to check again, okay, well, is x greater than 2? It is now, because now you've incremented x twice, and x started at 1, so x is now 3. Skip this line of code, it just won't read it because it reads those two as a pair, and it'll go to z. Great. But what does this actually do? We haven't really gone over that. So what does the actual program do? It's made up of nodes, as you probably noticed. Each of them has a section, and they run independently of each other. But what this is doing is saying, okay, so take, what are you looking for? Because you have your unknown here, right? So unknown is equal to y, because you can have inputs that are equal to 0. So it's not like the trigonometry where if you have an input equal to 0, or if you don't know what an input is, then put 0. Because here, the responses can actually be 0. So you have to use strings. String is, like, this would be a string. It's a series of characters. You can use numbers as a string, but it won't see those numbers as a number, per se. Not unless you convert them from a number to from a string to an equation or to a number. Cool. So if you run this code right here, you'll have, like, 2 of these will be y, and then 3 of these will be numbers. And you can't run calculations with strings because they're letters. You can't have 5y because it doesn't know what y is. It'll throw an error. So this is checking for, do you want or do you not know what string 1? Do you not know what the final velocity is? And if you don't know what the final velocity is and you have these 3 variables, then it will convert all the variables that you have into variables that you can actually use. And this is an equation. This is a function, let's say. Okay, let's say it is a function. So this will save it to y2. So on your graphing calculator, when you go to the graph, it'll save it as that y2 function. It'll say this is the y3 and this is the y4. And because it's just a constant, so it's y equal to 5, y equal to 6, y is equal to -3, then it doesn't matter where you call on it. It doesn't matter that it's, at 0 or at 100, whatever. It'll always be the same. So this is just going to be a number because it's a function at a specific location. And because it's a constant, it doesn't matter what location is, so this is just going to be a number. This is just going to be a number. This is just going to be a number. And you get these equations, and this equation, and this equation, and this equation, by doing the algebra with these equations. Say, you take the first equation, okay, well, how do you solve for d? Well, that's given. Okay, how do you solve for v? Well, you do this, you do that. How do you solve for t? Okay, well, you do this, you do that. And there you have every solution using just this equation. If you have v and you have d, and you want to solve for t, you can use this equation to solve for t. And you can put that into the calculator. It'll run it without having to do any algebra. It'll have your display, where here you don't have to save your output to a variable and then display the variable. You can just display the output because it's going to do this calculation anyway. It does that for all of the nodes. And you have the different comments here so I know what each one's doing, instead of having to read this and say, well, what does that one do again? What does that one solve for? What is that? I can just, it'll tell me. Right? I know what to say. This, okay, this is solving for distance. Okay, cool. We went over what the x is doing. It's making, did we? I forget. It's making sure that we ran all of this code, not the input, all of this code over all the nodes twice. Because if you can only run one of these nodes, because you only have 3 inputs, you can actually check to see, okay, well, we can calculate for the 5th desired output because we now have more variables. We have more data. So, yay. And it does that by just using x store 1 at the very, very top, and then checking to make sure that x is actually incremented correctly, so that x because this is only incremented at the bottom. So it's going to run this code and then check, okay, well, have we run this code twice? No? Run it again. Okay, have we run this code twice? Yes? Okay, great. It's going to see these two as a pair. It's going to skip over it. It's going to go to Z. It'll go to the very end of the program, because remember, this happened in a whole series. This was trigonometry was on the top, kinematics, and then ramps and friction and all kinds of stuff later. And then we're done. So it gets kind of complex when you're trying to program something that is that can have multiple inputs, and not all inputs are guaranteed. Like the quadratic equation, you know what all your inputs are going to be. You know that you're going to get pretty much the same output every time. But because the same type of output every time, but because you have multiple variables here, and you're not guaranteed all of the same variables every single time, you have to do some fancy hooba juba to make sure that you calculate all of the things that you want to calculate. Anyway, thanks for watching. Don't forget to like and subscribe. Comment if you have any other suggestions or questions or programs you want to see me make or comment on. And most importantly, don't forget to show your work. Have a great day, guys.